Integration with trig substitution. Let's do example 1. And let's try to evaluate the integral of 1 over x squared square root of 4 minus x squared dx. First, you should always first consider whether an integral can be done directly with a simple substitution or by part. Since none of these methods help here, we consider trigonometric substitution. The immediate objective here is to eliminate the square root term. We are going to be using the formula square root of a squared minus x squared. So since we have square root of a squared minus x squared, then we're going to be using the substitution x equal a sine theta, and theta is between negative pi over 2 and pi over 2. So therefore square root of 4 minus x squared, 4 is just 2, maybe write it down, this is the same thing as 2 squared minus x squared. So actually my a happens to be 2, so therefore x equal a sine theta means x equal 2 sine theta, and I want my theta to be between negative pi over 2 and pi over 2. Now since x is equal to sine theta, then dx is equal to cosine theta d theta. We will need x equal to sine theta to substitute into the integrand. We will also need the dx, which is 2 cosine theta d theta. We will also need square root of 4 minus x squared, which is square root of 4 minus x is 2 sine theta squared, which is equal 4 minus 2 squared is 4 sine squared theta square root. Now we factor the 4, we'll get 1 minus sine squared theta square root of the whole thing, which is equal 1 minus sine squared. We use the identity cosine squared plus sine squared equal 1, so 1 minus sine squared is cosine squared theta, which is equal to absolute value of cosine theta. Now this is just equal, absolute value of cosine theta is cosine theta because cosine theta is positive, since theta is between negative pi over 2 and pi over 2. Cosine, so this is negative pi over 2 to pi over 2. So cosine theta is positive here, and that's first quadrant and the fourth quadrant, which is positive. Now let's evaluate our integral of dx over x squared square root of 4 minus x squared is equal, the dx is 2 cosine theta d theta over x squared. X squared is 4 sine squared, x is 2 sine theta, so x squared is 4 sine squared theta, and then square root of 4 minus x squared, it's right here, it's 2 cosine theta, and the integral of the whole thing. Now we simplify the cosine theta with cosine theta, 2 with 2. We take 1 over 4 outside, and this is d theta over sine square of theta. Now to avoid substitution, what I'm gonna do, I'm gonna multiply negative 1 outside by 1 over 4, and then multiply by negative inside. So this is negative 1 over sine squared theta d theta. Now this is going to be negative 1 over 4. 1 over sine square is the cosecant square, so negative cosecant square of theta d theta. Now this is equal negative 1 over 4. Now we know the integral of a negative cosecant square is just cotangent theta plus some constant. Now the integral is written as a function of x, not as a function of theta, so we need to replace theta by x. Converting back to the original variable, x equal 2 sine theta. Well, we would like to draw a diagram. Since the substitution is x equal 2 sine theta, this means that sine theta is equal x over 2. So x is the opposite side, and 2 is the hypotenuse. So let's draw the triangle. So let's assume this is theta, therefore this is going to be x, this will be 2. Let's assume this side is c. This means that c squared plus x squared is equal to 2 squared. That's the Pythagorean theorem, which means c squared is equal to 4 minus x squared. So c is equal to square root of 4 minus x squared. Now let's call the integral that we evaluate in just number 1. So therefore 1 is equal to minus 1 over 4. Cotangent of theta is 4 minus x squared square root over x plus some constant c. So this is the solution. And that's about it for this example.